So here we have a variety of angles that are in radian form. And so we also want to be able to draw these type of angles in their standard position. So one thing to note is that as we label these axes, we're going to label them in radian measure. So for example, 0 and 2 pi is what the initial side will be. Now, also to help us out, what we could do is we could also make some of these values in terms of the same denominator. So 2 pi is the same thing as 8 of those pi over 4 increments. So you can think about how would, if it was 2 over 1, and I wanted to change that fraction to have a 4 in the denominator, I'd have to multiply top and bottom by 4 to get these kind of similar increments. So this right here is going to be a pi over 2, but again, in terms of increments of fourths, that's the same thing as 2 of the pi over 4 increments. Here we have pi, and that's the same thing as 4 pi over 4 increments. And again, 3 pi over 2, which is the same as 6 of the pi over 4 increments. And so this can help us out a little bit. Another part that can help us is a little bit to start drawing where the pi over 4 actually is. All right, so remember in a previous set of notes, the 4 in the denominator tells you how many of these equal increments you need to be able to move halfway around the circle. So here's 1, 2, 3, 4 of those increments. Now, to be able to find 7 pi over 4, again, I can just start counting how many increments I have. So 4, 5, 6, 7 would get me to a spot right here that I would have to move in that direction, that distance, to get to where 7 pi over 4 is. So a coterminal angle to 7 pi over 4 would be, say, this angle right here, where we are starting at 0 and going in a negative direction. So one thing also is being able to just look at the difference between these two values. So if I look at 8 pi over 4, which is going all the way around, and take away the direction I've already gone, that means that this little particular point right here is in a negative direction, only one increment of pi over 4. So again, it's the difference between going all the way around and that one small spot, but I need the negative of that distance because I'm going in a negative direction. All right, so negative 5 pi over 3. And again, so if this is my 0 or 2 pi, or sorry, yeah, 0 or 2 pi, going negatively would mean that this is a negative pi over 2. Negative pi. All right, so again, I'd be moving in a negative direction, those values. And again, if I want to think about those as thirds, all right, it would take negative of those 6 pi over 3 increments to get to negative 2 pi. All right, or I could think about, again, if I want to change my denominators moving around in these general directions, it'd be a lot easier to kind of move around. But these pi over 3s, remember the 3 in the denominator, means that I need to have 3 increments to get all the way around, or halfway around, I'm sorry. So, for example, this would be going down 1, 2, and 3. That would be 3 different increments. And with the pi over 3s, you got to be careful because the vertical axis kind of throws you off a little bit. All right? And so if I wanted to go negatively, I could go 1, 2, 3, 4. This would be a negative 5 pi over 3, which would terminate right here. And again, I could call this little section right here a coterminal angle, which again is the difference between going all the way around 6 increments versus the 5 that I only went. So I've got one of these little angles. And so if I were to start right here and just move up to that same terminal spot, I only am going 1 of the pi over 3 increments in a positive direction. So if I wanted to, I could go through and I could start labeling what all of these look like in terms of pi over 3s. I can't do that one. I kind of messed up there. But that would be, in this case, this would be a negative 1 pi over 3, a negative 2 pi over 3. All right. This would be a negative 3 pi over 3. All right. And so any of the areas where I would be on a terminal full section, and that's what I messed up here. I can't use that one. A full section, I can use that to help me out a little bit. Right. So again, let's look at increments of pi over 3, but let's move 7 of those. Hey, out. Sorry. All right, so if I move in a positive direction, 0, this is pi over 2, pi, and 3 pi over 2, and again, I'd get full and full rotation is 2 pi. That would be the same thing again as going 6 of those pi over 3 increments, right? Or over here, again, I would have 3 of the pi over 3 increments in a positive direction. So going 7 of those, I can see that I'm just a little bit too far. So again, the pi over 3s are right about here, all right? Make this a little easier. All right. And so 1 full rotation would give me 6 of those pi over 3s, and then a little bit extra. And so this would be drawing my angle in standard position. Again, starting from the initial side, moving around, and then showing where I terminate. All right. And again, I could also look at this in a variety of ways for a coterminal angle. Again, when we're talking about coterminals, we like to tend to think about, can we find an angle that is somewhere between 0 and 2 pi, or a 0 and negative 2 pi. So an angle somewhere in between these two spots. And so one thing I could do, again, is just start here and move in a positive direction and just go straight that direction, which would give me a pi over 3 increment, just as it did before on this example. So just going straight there. All right, so again, they have the same initial and terminal sides, and that can get me also a coterminal angle. Right. So let's look at some that are definitely way more rotations than what we have, because a lot of times we want to be able to unwind. Again, this is going negative, so 0, negative pi over 2, negative pi. I'm going to label some of these. All right. But again, with increments of pi over 4, this is the same thing as a negative 2 pi over 4. Right? Same as a negative 4 pi over 4. And so on. And so what we can do is, because this is further than negative 8 pi over 4, if I start taking away 8 sections of these pi over 4s, it will help me unwind my values here. So again, if I'm going in a negative direction, if I add an increment of of 8 pi over 4, that's like unwinding a full rotation, because 8 pi over 4 is the same thing as 2 pi in the opposite direction. So what I want to do is I want to add the same denominator, but add it to unwind, which is going to give me a negative 7 pi over 4. And so again, as long as I can stop with a value that's between 0 and 2 pi, or 0 and negative 2 pi, then I know where to basically end. So again, sometimes you like to draw in these nice increments to help us out to know where to terminate. And there's my pi over 4s. And so going in a negative direction 8 times gets me here. But again, that'd be 9, 10, 11, 12, 13, 14, 15 would terminate right here. All right. So again, I would have to keep going all the way around to get to that spot. So I could look at a couple of different things. This negative 7 pi over 4 is a coterminal angle with the negative 15 pi over 4. And this would say, I'm just going to start here and then just go straight there. I don't need to continue around to get there. And so that would give me also another coterminal angle to just get there in one straight shot, go negative 7 pi over 4. All right, again, if I wanted to, I could also find a second coterminal angle. And what if I just went this direction? That would be the same as moving in a positive direction, a pi over 4 increment. So more than one, obviously, coterminal angle when we're dealing with radians also. So now look at the negative 21 pi over 6. All right, so again, in a negative direction, if I think about increments of pi over 6, that means it takes me 12 of the pi over 6's to get one full rotation, because that simplifies to 2 pi. All right, so again, a negative pi over 2, all right, negative pi, or negative 6 pi over 6, kind of help me out a little bit with that. Negative 3 pi over 6, all right. Negative 3 pi over 2, which is, if I think about increments of 6, is negative 9 pi over 6. All right, so some of that will help us out a little bit. But again, I want to think about adding or unwinding these increments of pi over 6's. So if I add a 12 pi over 6, that will help me unwind the rotation once to figure out where I terminate. And so this is where you might need your calculator so you can figure out what that looks like, which in this case is a negative 9 pi over 6. And again, that is a number that's smaller than going in a negative direction 12 of those 1/6 increments. So if I want to add in about where 1/6 is, or a pi over 6, remember I'm going to need to think about how many of those increments do I need to get halfway around. So because the denominator is 6, it's going to take me 6 increments to get halfway around. If I'm going in a negative direction, I want to stop at negative pi over 6. So unwind once, and then keep going till I stop right here. And I'm actually going to stop right here on this axis. All right, and that's okay. That happens. You don't have to be in a quadrant. All right, but again, if I think about simplifying this fraction, because negative 9 pi over 6 is not a simplified fraction, a coterminal angle would be negative 3 pi over 2 if I simplified that fraction. Again, I wrote that up here as well. Negative 3 pi over 2 is the same as negative 9 pi over 6. Or again, if I wanted to just do a straight shot straight there, a coterminal angle, another one would be just a positive pi over 2. So that's another coterminal angle. Right. So let's do one more. Again, let's move in a positive direction this time. And so if I'm moving in a positive direction, again, I'm going to label my values along my axes here as positive values. All right. So to get full rotation gives me 12. So if I want to, again, figure out how many rotations, I'm going to have to subtract off now 12 pi's over 6's to figure out how many rotations are really there. All right, so if I take this 29 and I subtract off 12, that gives me a 17 pi over 6 left. And 17 is still larger than 12, meaning that I still have more rotations that I need to subtract off. And again, I'm going to say that that terminates at 5 pi over 6. And that is a number that's between 0 and 12. And again, let's draw in our pi over 6's. They don't have to be perfect. But you do want to have something to kind of refer to. But again, if I were to go one full rotation this way, pi is the same thing as 6 of those pi over 6's. It took me 6 increments to get there. So I'm going to have to go one full rotation to get 12, right? Another full rotation to get 24. And then this would be 25, 26, 27, 28, 29. And then I would terminate right here. That would be my coterminal angle. Or, sorry, my terminating side. So a coterminal angle would be my 5 pi over 6. Right. I could also, if I wanted to, go backwards and start here and go down 1, 2, 3, 4, 5, 6, 7 as well. And so in a negative direction, 7 pi over 6's. Right. And so that's just a look at how to draw a radian in standard form and to identify some coterminal angles.